load factor is nothing but a ratio between ultimate load divided by working load. Okay. Now load factor can be found out by another formula also, factor of safety into shape factor. If you have these two components, you can find load factor. So factor of safety is there in your IS 800, table number 4, page number 29. So here you have the partial safety factor. This is partial safety factor for loads. What is table number 5? Partial safety factor for materials. For load factor, which partial safety factor you should use? In the name it identifies. What is load factor? So the component is load here. So you have partial safety factor for loads. So you have to take this at the annexure H. This is the annexure H. Here you have the shape factor. Okay. If you know that, you can find the load factor. By the code book itself, you can find the thing. This component depends on nature of loading, support condition and mode of failure. What is the formula here? Factor of safety. Factor of safety depends on what? Dead load, live load, earthquake load or wind load. You have this component. That is why it is indicated here as nature of loading, support conditions. If it is fixed, hinged or roller, and mode of failure. Load factor depends on these three factors. Okay, what are the factors which depends on shape factor? Dimension of the object. Dimension in the sense, if you are placing one object in x and y direction, you will be getting one dimension, and if you place in another axis, you will be getting the width is different and depth is different. So the shape factor solely depends on geometry. It depends on geometry, but the load factor depends on what? The factor of safety, which depends on three components. Find the difference between these three. Normally the load factor is 1.7 to 2 is used for plastic design. So when you are designing for plastic analysis, load factor you should be knowing that around this limit is there, then it is good. Why? Because at 10 kilonewton meter the material achieves elastic stage. You should give 20 kilonewton to reach in order to break. It should not break that 10 kilonewton is elastic, at 11 kilonewton it should not break. When you are designing any section, the plastic stage range should happen only after 2 times of that. If it is 10 as the elastic limit, plastic limit should go beyond 20, so that the material will not break immediately, it will lapse longer. Okay, take down the next problem. Determine the shape factor for a triangular section of base B and height H as shown in figure. This is a triangle, and from this triangle you should find the shape factor for this. In the previous class we have derived for rectangle, yes or no? We have derived shape factor for a rectangle. Now we are deriving for a triangle. Okay, now you recollect your formulas. ZP by ZE, that is the formula. When you divide this section by 2, are you getting 2 section or 3 section? You will be getting only top and bottom. So you can use what formula? ZP equal to A by 2 Y1 bar plus Y2 bar. Okay. Now, what is the moment of inertia formula for a triangle section? PH cube by 36. For a rectangle section, BD cube by 12. For a circle section, 5d power 4 by 64. These 3 sections, as a civil engineer you should know, these 3 are the basic shapes. If you know the moment of inertia, it is easy for rest of the things. Now you can find ZE. ZE equal to I by Y. What is I? I is given here. Y is the toroidal distance from the neutral axis. See, this is the neutral axis. Z is the neutral axis. From the neutral axis, you will be getting centroid at 1/3 of height. Yes or no? The rest of the distance will be 2/3 of height. So this is the total height. Hence, your finding from the top, you will be getting 2/3 of height. You can divide this to, what will be your answer? ZE equal to B H square divided by 24. You will be getting this answer. Now ZE is over. You have to find ZP. How to find that? You need, what are the components? Do you know the formula for finding area of a triangle? Half base into height. You know area component. Y1 bar plus Y2 bar. You have to find these two. What is Y1 and Y2 bar? Distance from equal area axis to the centroid of top section. Centroid of top section is Y1. Distance from equal area axis, what is equal area axis is DE. What is that? If I am cutting the section by equal area axis, my area will be equal at both top and bottom. But in the neutral axis, if I am cutting, it may or may not be equal. When it will be equal? If you are having symmetrical section. For a rectangle, if you are cutting the section, top and bottom will be symmetrical, yes or no? Then both are same. If I am cutting for a triangle, will it be same? No. So that you will be getting, this is neutral axis and D and E is equal area axis. So Y1 is what? What is Y1? Equals distance from equal area axis to centroid of top portion. Okay, if this is the equal area axis, where you will be having the centroid? Imagine that this is only a triangle. This is a triangle where you will be having this centroid distance. So what is the dimension? This is what? B1 and this is what? H1. This is a small triangle and this is a large triangle. This is total H and total B. Now let DE be the equal area axis. What do you mean by that? This is equal area axis. Then you can equate that. What is the formula for this area? Half B1 into H1. So this is half B1 into H1. Then your bottom area, how you can find? Bottom area is, you can find out by, what is the total area? Half into B into H. So if you divide by 2, will you get the half of the rest of the part? Yes, this is what it is done here, BH by 2 into half. If you equate this, will you get B1? You can simplify this, 0.5 and 0.5 will get cancelled, B1 H1 equal to BH by 2. This will be your equation. Then what will be B1? If you need B1, you can take down H1 outside, it will be B1 equal to BH by 2H1. Now, from similar triangles, what do you mean by similar triangle? A, B, C. This is a triangle and you have a smaller triangle as A, D, E. Do you have the two triangles? All are similar triangles. Okay. For the similar triangle, H1 by B1 ratio will be equal to H by B. This is a component of similar triangle. I can draw many number of triangles with this ratio. I can draw a higher triangle and more higher than that, the ratio will be same. What is that ratio? H1 B1 will be equal to H and B. This is the equation. Now from here, can I find H1? You can cross multiply B1. So what will be your answer? H B1 divided by B. So this will be your answer. H B1 divided by B. Now you have found out B1 and H1. From these two equations, you can find the next component. How to simplify further? Do you know H1? HB1 by B. If I am substituting instead of H1, HB by B, what will happen? This will be getting divided by B, it will go to top, and if you simplify this, what are the common factors are there? H and H is the common factor, you can cancel it, you will be getting B square by B1. So you can cross multiply this and B1 and B1 will get B square. If you need B1, you can take this outside, you can root that, B square will become B, 2 will become root 2. If you want to find B1, you can use B by root 2. The same way, here you have H1. The B1 value you already know, 2H by 2H1. Instead of B1, you have to substitute the component BH divided by 2H1. What are the common factors here? B and B will get cancelled and you will be getting H square. The same way you will be getting H1 equal to H by root 2. Now, you know this is the equal area axis, this will be Y2 and this component will be Y1. This is Y1 and this is Y2. Okay. Now you need the Y1 factor and Y2 factor. You can find out by using, they have given H1 equal to H by root 2. We have already found this, B1 equal to B by root 2. What is the total area? How to find total area? Area of this triangle is half BH, which is written here. Okay. Now, what is Y1 bar? How will you find the centroid of Y1? 1/3 of height. So, what is your height here? H1. So, 1/3 of H1. Do you know what is H1? H1 is H by root 2. So, instead of H1, you substitute H by root 2. You will be getting this answer. Now, you have to find Y1. Y1 is over. Then you have to find Y2. Okay. Do you see a trapezoid here? Y1, the top part is a triangle, the bottom part is a trapezoid. So what is the formula for finding Y1 for a trapezoid? So this is the centroid, no? You will be having a centroid at this trapezoid. This is the centroidal distance. If this is Y, the formula is, you can write it down, for a trapezoid, for finding the centroid from the bottom, it is H by 3 B plus 2A divided by B plus A. Okay, you need from the top. From the top, what is the distance is known as Y2, isn't it? This is the equal area axis. From the top, what is the distance? For calculating this, you can use H by 3 2B plus A divided by B plus A. You can use the same formula in opposite way. Y2 is what? What is the formula? H by 3. So what is your H here? This is your overall height. How to find this height? Capital H you know, that is total height and this height. So if you subtract these two height, will you get this height? Yes. So this is your height. So this distance can be found out by subtracting H minus H1 by 3. Now 2B. So what is the B component here? B component is 2B and what is the A component? A component is what? B1. So you have to substitute B1 here. Divided by what is A and B? Here B1 plus B. This is what is written here. Now you can simplify this. Do you know H1? What is H1? H by root 2. What is B1? B by root 2. You substitute this component and find Y2 bar. See, instead of H1 you can substitute H by root 2. Here we have written H by root 2 and instead of B1 you can write B by root 2. Instead of B1 here you have written B by root 2, this is 2B and here you can write B by root 2 and this is B. Now what you can do is you can take the H commonly. Hence if you have 2H here you can take a H commonly and here also you have B here, B component. The B component you can take it outside. Here you have 2B, you can take it outside. You will be getting 1 plus root 2 and 2 plus 1 by root 2. This will be your answer. and if you add 2 plus 1 by root 2, you will be getting 2.7, and 1 plus 1 by root 2 will be 1.7. If you divide this and multiply, you will be getting 0.1548 H. Okay. Now applying all the components, you know A by 2 is BH by 2. So BH by 2 divided by 2, which will become BH by 4, and this is H by 3 root 2. H by 3 root 2 is written here, 0.155 H. You can add this component. If you add these two, you will be getting 0.0976 BH square. This will be your ZP. If you divide ZP value divided by ZE, your ZE was BH square by 24. Both the components might get cancelled. After cancelling these two, you will be getting an answer of 2.343. So the shape factor for a triangle is 2.343. What is the shape factor of a rectangle? 1.5. What is the shape factor for I section? 1.14. Now what is the shape factor for this triangle? 2.343. Okay. If you are getting 3 shape factor like that, which section you will be using for designing your beam? You have 3 sections. One is rectangle, one is I section, one is this triangle. You know all the 3 value. Which shape will you use for your beam? You will use rectangle. Rectangle is having 1.5 shape factor. Why you want to use that? What is the advantage of that? Easy to construct, yes. See, if you are making a triangular beam here, it is not that much easy to construct. Pouring the concrete, then casting, then filling the gaps, it is very difficult, and plastering is also very difficult.